Okay, this is going to sound like something straight out of science fiction, but I promise you it's happening all around us. Today we're going to explore how ants, yep, ants with brains smaller than a single grain of sand, are solving problems that can totally stump our most powerful supercomputers.
I mean, just think about that for a second. It seems completely impossible, right? In one corner, you have these incredible supercomputers, the pinnacle of our engineering, chugging through trillions of calculations a second. And in the other corner, an ant. So how is this possible? That's the paradox we're going to unpack today, and the answer is not only fascinating, it's changing how we think about intelligence itself. So, the first big clue to solving this mystery is that we have to shift our perspective. We're not really talking about a single ant. No, the real genius, the real computational superpower, lies in the collective, the entire colony acting as one giant, distributed brain. See, a supercomputer has a central processor, a boss that tells everything else what to do. But with ants, there's no leader, there's no one giving orders. Instead, you have millions of individuals, and each one is just following a few very simple rules. And somehow, out of that, this complex, intelligent system just emerges. It's intelligence that builds from the ground up, not directed from the top down. All right, so let's get into the nitty-gritty. How do these two brains actually think? Because believe me, their approaches to solving problems are operating on almost opposite principles. Let's break it down. And here's where you can really see the difference. A supercomputer is kind of like a control freak. It has one central command, it follows incredibly complex instructions, and it absolutely needs perfect, clean data to work. The ant colony, on the other hand, is a master of chaos. It thrives on uncertainty and messy information. Each ant just follows simple local rules, and together, they form a massively parallel system. Think about it, millions of tiny processors all working at the same time. So the theory is cool, but what does this look like in practice? Let's take a look at some of the toughest computational problems out there. Problems that ants solve for breakfast. Okay, this is a really famous problem in computer science. Imagine you're a salesperson and you have to visit, say, 30 cities. You want to find the absolute shortest route that hits every city just once. Seems simple enough, but for a computer, as you add more cities, the number of possible routes just explodes. It becomes exponentially harder to solve. But for ants, finding the most efficient path from the nest to a bunch of different food sources is just, another Tuesday. So how in the world do they do it without a map or a GPS? Well, it's this incredibly elegant, self-organizing system. It starts with ants just exploring randomly. As they walk, they leave behind a trail of chemicals called pheromones. Now here's the brilliant part. An ant that takes a shorter path gets back to the nest faster, so it can make more trips in the same amount of time, laying down more and more pheromones on that short path. That trail gets stronger, which attracts even more ants. And over time, the whole colony just naturally converges on the best, most efficient route, all without a single ant ever knowing the big picture. It's amazing! And this beautiful process actually has a scientific name, stigmergy. I know, it's a bit of a mouthful, but the idea is actually super simple. It's just a form of indirect communication. The ants talk to each other by changing the world around them. That pheromone trail is like a message left on the ground that just says, hey, this is a good way to go. It's a full-on conversation without a single word ever being spoken. And finding paths is just the beginning. Ant colonies are absolute masters of logistics. They're constantly balancing workloads, assigning ants to forage or take care of the nest. If a path gets blocked, they find a new one almost instantly. And get this, even their mistakes are useful. An individual ant wandering off the beaten path isn't a bug, it's a feature. It's exploration, and it prevents the colony from getting stuck on a bad solution. It makes them incredibly resilient. And here is where it all comes together. We're not just admiring these little geniuses from a distance. Scientists and engineers are now taking these ancient algorithms and using them to solve some of our most modern and complex challenges. In fact, this has inspired a whole field of study called swarm intelligence. Researchers are designing algorithms that literally mimic the collective behavior of ants. They're often called ant colony optimization algorithms, or ACO for short. We are essentially creating digital ants to solve our problems for us. And don't think this is just some theory. Look at where this is being used right now. Optimizing airline schedules, routing fleets of delivery trucks, even designing the physical layout of microchips and organizing massive data centers. The simple, elegant logic of the ant colony is now powering some of the most sophisticated technology on the entire planet.
So this all brings us back to our big question from the beginning. Who is smarter, the ant or the supercomputer? Well, it turns out that's the wrong question. It's not about one being smarter than the other. It's about different kinds of smarts. Supercomputers are geniuses at precision. They excel at exact calculations when they have all the data. Ants, on the other hand, are geniuses of adaptation. They excel at finding good enough solutions in messy, unpredictable environments with incomplete information. They are two totally different tools, each one perfectly optimized for a different kind of problem. And this really just gets to the heart of it all. What ants prove is that true intelligence isn't just about raw processing power or speed. It's about being effective, being resilient, and finding solutions that actually work in the real world. So we're left with this final, really exciting thought. The natural world is basically a giant laboratory that has been beta testing solutions to complex problems for millions of years. And if we can learn this much from the humble ant, just imagine what other revolutionary algorithms are out there just waiting for us to notice.